sekarang we'll continue to the part 2. Yes, I'm starting this course in 9:50 because we have some appointments. There are some of my students that are need for advice in their research, and also I'm having a breakfast first, so it is fair right now. So in this example in here, you can see we already tried to run these applications, but it turns out that the applications is closed. Why it is closed when we are select the applications? Because I have do something wrong. Similar to the previous one, this is the problem. Screen fill, etc., etc. 00. I forgot to add another what you call that? Kurung brackets. Okay, in here. So I have to address this one out. Okay, and the clock tick, it's already right. Yeah, it's already right. Yeah, because we need 30 seconds before the application is closings. And I think we already tried to display it will grow. Okay, and then this is the main event in here. We are trying to create the circle over here. Okay, we already defined the width and the height times 2. So the opening will be a small circle. Okay, and the width and the height we already defined as 500 and 500. Okay, on top of it, when we are defining the plot circle Bresenham, which is our main what you call that, our main functions in here, we already define how to create the circle itself. So in here, wait a minute. Okay, in here we already defined that the x will be 0, then y will be the radius that we already sent from the previous functions called using the parameter called radius. And then in here, the radius, I think I mistyped. It should be 5 per 4.0, as I said in the previous video, but I forgot. And since I'm maybe a little bit hurry because I want to catch up to be able to attend the week of prayer this morning, that is my problem in here. Okay, and after that we go to the silicon points 8 way that it is defined over there in the top. You can refer to the reference book. I already shared the screen, the book names, titles, but not the PDF because it is not ethics. If I share the PDF to you, you have to find it yourself, or maybe if you want to get the printed one, you can find it in the library. Okay, and this is the functions to define the circle. Okay, hopefully after we are changing this one, okay, the diameter is already defined in here. Okay, the circle point 8 ways is already defined. Wait, it should be over here. Okay, that's why I really hate Python, because I miss this one, curly brackets. Yeah, by having a curly brackets, I can know which code is a part of a whole programs. That is the problem using Python. Yeah, you have to take a good notice about the positions of the code. If we put over here, it will be outside of while. If we put over here, it will be inside the while. But for example, if we put it over here, it would be a part of the else. That's the problem. That's maybe the problems when our code is not showing anything. Okay, and hopefully around it is still showing everything, since I have to find out what is the real problem of it. And yeah, I have to retype. Yeah, I forgot. I'm cutting the line of codes, but I forgot 2 pages somewhere else, so I have to rewrite all of the codes, or maybe I will copy from the what you call it, well, from the example from the book. Okay, for now I will try to run the applications and hopefully it works. Hopefully. Yay! It works. So the main problem, why it is not showing and just closing, because we are defining this one, the diameter is 4 per 4.0. It should be 5 in here. And we forgot to have a second bracket in here when we are screen and filling. That is a chain reactions why it is going wrong. So for now, we already create a comment in here for our run demo OpenGL cube. Why we are creating the comment in here? Because I don't have time to explain in the previous part, yeah, because of the time. Yeah, maybe I should wake up and then run the code. Yeah, since I haven't do that properly. So now we are going to the cube one. Okay, I'm sorry if you can hear my daughter screaming, yeah, because it is the way of children. They love to screaming, to laugh, and etc. And it is still holiday, so it's their time to express themselves. Okay, so for now we will try to create a simple cube in here, and we have to import the OpenGL properties. Okay, I will copy from the book you can find in the reference book. Okay, and you can pause the video anytime. Okay, I already explained to you what did I do over here. So our problem from the previous code, I forgot to add OpenGL.gl. I make it OpenGL import. That's why there's an error over here. Over here. Where is the error over here? The OpenGL is not working properly. This one. From OpenGL import. Since I'm from OpenGL import, it should be OpenGL.gl. Like this. That's the problem, the previous problem, and it is now fixed. Okay, so you can pause the video anytime you want. Okay, and now we will continue, shall we? Okay, well, we will try to create a cube. What defines a cube? A cube will have how many? 7 or 8 vertices. It should be 8. I don't know why am I writing 7 over there. I said 8 but I forgot to mention. Why 8? Why 8? Because a cube consists of 6 faces. And you can see from every corner there will be 8 corners. So that's define the number of vertices. So should we define the own vertices in here? Yes, you can. You can define the vertices over here. Okay, but if you want, or if you didn't want to, what you call that, define your own vertices, you can create another functions to declare the vertices. Okay, but for now, we will try to focus on wait, I'm lost in my own code. The functions to run demo OpenGL cube over here. We will focus on that one, and then as we did the same thing with the circle, now we will try to finish all of the required functions to be able to run the functions run OpenGL cube. So for now, I will copy this one. Okay, and we will define. Okay, we will define the OpenGL demo. Where should I put it? I believe below the demo circle, because the first key when pressed is K1. We will run the run demo circle. The second one will run demo OpenGL cube. Okay, So for now, I will put it over here. Dev run open demo OpenGL cube. Okay, don't worry about this error because we haven't put anything. If you put return in here, it will define that is the end of the functions. And that's why I still prefer to have a curly brackets over here so I can know what is the end of all. Yeah, since in Python we are defined by using only the columns, the columns in here. Yeah, that is the problem. Yeah, because I'm not used to use columns. I still prefer using curly brackets. Okay, we will define the width and the height. Okay, as 600 by 600 in here. Okay, and the screen, if you are lazy, yeah, like I am. No, I'm not that really lazy. You can copy paste, but the problem is the previous one are using Pygame two-dimensional mode, whereas in this example we want to utilize the OpenGL. Yeah, we want to utilize the OpenGL. So we are not using that two dimensions. We will define a new functions screen as set Pygame. Yeah, ignore the sound. Yeah, it is the warning from what you call it, Visual Studio Code to tell me that it is not a defined functions. Yeah, I know I'm defining my own functions. Yeah, so yeah, that's the tool. I want to change setup, but it is not properly. Okay, set Pygame OpenGL mode, and then we define the width, and then height. Okay, and also the same captions. What is the captions? Yeah, I will take from here, a cube 3-dimension demo over here. Okay, so the screen will be based on the set Pygame OpenGL mode with height a cube 3D demo. So as similar with the previous one, I'll try to finish this whole functions, the run demo OpenGL cube. After that, we will do every undefined functions. Okay, now we already import some of the OpenGL GL libraries such as GL click color, GL enable GL, GL line width, and we will utilize all of it. GL clear color over here will define as 0.0. Okay, 0.0. Wait a minute. 0.0, 0.0, 0.0. So it will be black, and then the opacity will be 1.0. If we want to make it a little bit transparent, you can set as 0.6 for example. But it is not important since we are using a command line. The transparency is it doesn't really matter. When we are trying to render a rasterized versions of it, the opacity will show. So for now we will use 1.0. We want to have an what you call that, a visible cube. Yeah, don't create another problem. GL enable, we are using the GL depth test. Okay, and then GL line width, we are using 2.0. If you want to make it thicker, you can use 3.0, etc. Okay, and we also define the perspective. Okay, the perspective yeah, you can see the 30 is the value of the angle, and the width and the height will define the actual surface that we are working on, the opacity, sorry, the increment, Okay, that you can follow the theory behind this in the chapter 3. And then we will try to move the camera. Okay, this is defining the perspective. Okay, perspective. And then we'll try to move the camera so it will be visible. Okay, glue dot translate glue translate sorry glue gl translate f. Yeah, the distance will be from 0.0 to 0.0, and the third axis, since it's three-dimensional, we will retract three axes, so it will be shown as um, three axis depth from the center. I think it is much easier when you are seeing the results. Okay, minus 3.0. Okay, later on, maybe in the next week, I will try to draw in the whiteboard because it is hard to draw in here since I'm not having any touchpad. Not touchpad. Uh, what you call that? The pad to draw something, drawing pad. Yeah, and it is hard to draw using your trackpad. Okay, and now we will use a mesh for our cube. Mesh will be, our cube. Okay, wait a minute. Cube and a clock. You already know about the clock. Pygame dot time dot clock. Okay, and then done. False. Okay, please forgive my children when they are screaming a lot. Yes, remember this is holiday, so I'm not asking you to do all of this in this holiday. You can enjoy the holiday, but please be wise. This is a substitutions for our class for today. So please spare your time to understand this video and maybe to do the walkthrough. And remember, you can pause anytime. So if you don't want to create an expression, you can skip forward. But if you want to try to understand the code, you can listen to the explanations. Yeah, that's why this video feels so long rather than other tutorials, because I'm trying my best to make sure that you are understand this codes. Okay, while not done, for event in pygame dot event dot type dot get. Okay. If event dot type is quit, this is the same with the other example. Pygame dot quit, and then system sys dot exit 0, immediate exit. Okay, if event dot type is key down or key pressed, and event dot key escape. Okay, we will set this loop as true, so it will exit from only the loop, not quitting the applications. Okay, now if the requirement are not met, the user is not pressing any key escape, not selecting to quit, so the user want to continue. Now we are drawing the mesh, but before that we have to clear first. GL clear color buffet bit and the depth GL depth buffer bit over here. Okay, this is the masking. Okay, for clearing, where we are clearing the buffer by the both color and also the depth. And then we will try to rotate each frame. So these functions over here, okay, we are trying to rotate the cube by using the transformations functions or rotate functions, gl rotate f. Okay, the angle will be 2.5 degrees. Okay, the x will be 1, the y will be 0, the z will be 1. So it will be rotated in the z and x-axis. So you know the, what you call it, this is the x line, this is the y line. You can follow the cursor over here. Okay, the z line is go like a diagonal one, but it is actually the depth. Yeah, we are thinking in the 3 dimensions. So it will rotate on the x like this one, not this one. This is the y rotations. The x will rotate like that, and also in the z directions. Yeah, you can just imagine the rotations. Okay, and now the most important one, we draw the cube. Mesh dot draw. Okay, and don't forget to pygame dot display dot flip clock tick 30. Okay, the frame rate will be 30. Okay, when we are trying to to run these applications, it will show uh, what you call that, a problem because we haven't defined the cube in here. Okay, and we haven't defined the set pygame OpenGL mode. So for now, we will try to set pygame OpenGL mode. Yeah, I will try to copy this one because we will have the width, height, and also the captions or title in here as a parameters when we are trying to define the set pygame OpenGL mode. Where do we put it? That's a good questions. You can put on top of the menu. Wait a minute. Okay, below the pygame today mode. So now we are defining the set pygame OpenGL mode. Yeah, def in here, width, height, and also this one will be title, the same. And title. Yeah, it will be colored darker gray when they are used. We haven't used that one, so it's not a problem in here. Okay, so we will set the display. Okay, what is the differentiation when we are explaining using the two-dimensional mode with the three-dimensional one? Two-dimensional, we are only using the x and y axis and not using any OpenGL. In here, the differentiations, we are trying to utilize the OpenGL to enable us to create a 3D illusions of the cube rotating. Pygame.display set mode. Okay, we define as width and also height in here, and also we are using double bulb, and the most important one, OpenGL. Okay, and the next one is not really important, but it's a good display that you create captions or titles on top of the menu, on top of the display. Pygame dot display dot set captions to be title. Good. Okay, and then we are returning a screen. Return the screen. Okay, Now, can we run? Of course, you can try to run, but it will show an error because remember you still have some functions that is not defined yet. See, nothing is working, and there's an error. So it is working when you are trying to compile it. It works because it is only the menu. But when we are trying to assess, oh sorry, I press the first one, yeah, escape to back to the previous menu. And to access the second one, the 3D, a cube rotating one. OpenGL Mesh 3D, it shows an error because we haven't defined any cube in here. So for now we have to define the cube in here. So how can we define the cube? By define an answer, the cube itself. Okay, the cube is can be a little bit hard. I will show the example, the output when we are trying to rotating in the OpenGL. Yeah, and this one, this already having a mesh inside. Okay, but if I don't want to implement any mesh in here, yeah, I can ignore the mesh. Yeah, I can ignore the mesh in here, but yeah, I'll try my best to still include the mesh. Okay, this is the all corners is the vertices that I talk about. The lines are creating by defining the mesh, and also when we are to trying to create a triangle inside every cube, you see there are some triangles in here. I know you may look dizzy because looking at this one, it's really cute, it's really cool. Yeah, we have to define the mesh. So shall we create a cube? Where should I put the cube? That's a good questions. The first one, you can use below, or I think yeah, below when we are defining the circle in here. This is the circle. Okay, the circle that ends in here, and now we are trying to defining the mesh. Okay, and defining the cube. If you want to, you can try to not using any mesh. So in here I will define cube, and it will work like a charm. But the problem is, yeah, we will try to not using any mesh first. Okay, we will try to not using any mesh. What will be the differentiation? We are not using any mesh in here. Sorry. Okay. Def initiation, self initiations are using super initiations, and we are defining the vertices. Okay, this is the same as the book example on cube.python. Okay, if you want to make it shorter, you can copy and paste, or maybe you can have an OCR and then scan it and then paste it. Like what I will do in here, I will copy from the book. Yeah, I'm opening the book over here. Actually, I already compile all of the codes into a folder for each chapter. So I will just copy and paste. Yeah, I know it will take a lot of spaces, but you can write it as it. It's not a biggie. You can try to write it as this. Yeah, it will define the position and also the translations of the cube. Yeah, I know it may be look similar, but it is not that similar, so you have to be cautious when you are trying to implement this one. Okay, see, it looks like similar, but it is not similar, so be careful with that. Yeah, that is my what you call it, advice in here. It's not the same because this one represents the x-axis, this one represents the y-axis, this one represented the z-axis. So you have to be careful, really careful. Yeah, I know copy paste is much more logical than typing itself, but be careful. Once more, be careful. I know there may be a repeating sequence, but it is for a different sequence. Okay, if you try to do this one, you have define the cube itself. Can you run it? Let's try. Wait a minute, I run the wrong applications. No, because the mesh is not drawn yet. Okay, the draw, okay, in OpenGL is not defined non-type object as attribute draw. Okay, if you are open to the line 214 over here, see mesh dot draw. Mesh is the cube, but why the mesh is not drawing? Because we haven't declare the drawing functions in here. So it is you have to be careful when you are trying to do anything. Yeah, we already defining the rotations. We are defining the mesh as the cube itself in here. Okay, but we haven't defined the whole need the translations for the mesh. So we have to fill that one. Okay, we have to define the mesh in here. How we define the mesh? By creating the mesh. Okay, wait a minute. Okay, I will give the name will be the mesh 3D in here. Okay, wait a minute. I'm a little bit curious. Is it because of the mesh or because I'm not? Wait, yeah, I'm a little bit curious in here. I think that is the problem. Two, yes, the same. Yeah, so it's okay to make it like that. Yeah, I'm just curious, or be cautious. Yeah, because you maybe have some typos in here. You have to make sure that it is not a typo. Okay, so the next problem is we haven't defined the self in here. Yeah, we have to define the self. That's why we have to utilize the mesh. I'm using the name mesh 3D to make a differentiation between two-dimensional mesh, or as you know as grid layout, as we already established in the last meeting. And now we will define the mesh 3D. Okay, I know the next. Maybe this is the problem. I'm using define, not class. I know, sucks. Yeah, the same. Cube object has no attribute draw. Yeah, it's still the same lah. Yeah, we are defining class will show as a method that have a return like that. Yeah, or we define as a separate class. We are not defining a functions. In here we are defining a class. A class. Okay. Def. Sorry. Class 3D mesh 3D. Okay. def init as self. Okay, and this is the default example of the actual vertices without any vertex in here. The actual mesh self dot vertices will be, okay, this one. If you want to copy paste this one, yeah, this sixth one. Yeah, but if you want to be more careful, yeah, you can try to write it yourself. 0.5 means 0.5, 0.5, comma, okay, negative 0.5, negative 0.55, still positive 0.5. Yeah, I know there will be much more prone to typo in here. 0.5, 0.5, 0.5. Okay, the next one will be the negative, positive, 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 negative, and negative, positive, negative. The convert of this one. Okay, so this one will be negative, positive, positive. Wait a minute. Okay, then this one will be positive, positive, negative. Okay, the last one will be negative, positive, negative. You have the, what you call that, kebalikan, mean 0.5, positive, negative, like this. Okay, we already defined the vertices in here. Now we also have to define the triangles inside. Yeah, I don't want to use any triangles. It's okay if you don't want to use any triangles, but since I already show you the actual output of this code, maybe we will use the triangles. Yeah, if I'm being lazy, I can copy paste from this one, but ya udah, just let go. Triangles. Okay, 0, 2, 3, 0, 3, 1. Yes. Okay, and then we will define the draw. Okay, I will just copy from this code over here to make it shorter. This one. Yep. Like this. It will create a multiplications of the triangles. Can we try to run it? Yes, you can try to run it, but first we haven't defined any triangles in here, so I will copy from the code. And there's the triangles. Yeah, same as in the cube.py. So my workflow is the first one. I will try to create what you call that, guideline for me when I'm trying to create an applications. Okay, this is the triangles. You put it inside the cube mesh 3D. The triangles will refer to the self triangles in here and to the drawing itself. Shall we try to run? Or I will scroll from the top to below to the bottom. So I will clear some of the negative spaces in here. Okay, the first one, we are importing the sys, we are importing the math. Yeah, I know we are not accessing as all at all in this case, because yeah, I have an actual curve mathematic using the math, but since we only use the circle and also the cube, I'm not using that math for now. Yeah, maybe in the next event or our next class we will use the actual math, because it is still a simple mathematic um, calculations. Okay, so if you want to erase this one, you can do that, or having as a comment. Yeah, but if you are importing that one, it's also not a problem. Why? Because it will not affect anything, rather than only adding a new line to your overall code. Okay, so pygame local import, we are importing some of the events in here, but we are not using mouse anytime for now. I think the tutorial is really long enough, so I will not make it any what you call it difficult. We just stick to the result of creating the cube. Okay, the next one, we are fixing the OpenGL import. There in the first part, I tend to forget to adding the GL library in here, and also the GLU. You have to make sure that is using the GLU, not OpenGL only. Okay, the circle points in here defining the actual circle, and we already finished that one, so it's not a problem. Mesh 3D, I'm just explaining to you the Mesh 3D to creating the vertices and also triangles index list, or as a reference in here. Okay, and the next one, the cube one, is the actual usage of the cube. We are connecting every vertices in here. Okay, so the next one, we are defining the pygame OpenGL mode in here. Okay, the menu loop. Yeah, don't forget we have to remove the what you call that comment line in here, the hashtag. Yeah, you have to make sure that it is accessible. Yeah, what is the point of creating all of it when you are still setting as a comment? It will not run. You're just wasting your time. Okay, and the next one, demo circle, we already finished by with that, and the demo OpenGL cube, we are already set the height and the width. Okay, we are set screen pygame OpenGL mode in here. Okay, we are defining the screen GL clear color, defining the RGB alpha in here. We are using the GL enable by having the depth test. We are defining the width of each line as 2.0. If you want to make it thicker, you can select 3.0 or etc. We are moving the perspective. Okay, using 30 and then reference as a width and also the height. Okay, and the power and the number of the perspective. We are translating the camera move to be farther. If you want to make it the cube little smaller, you can increase this one. For example, -5. The cube will shown as far more further. Okay, we already defined the mesh and cube. We already defined the pygame time and also clock that we set as 30 seconds in here. Okay, and in this logic, when the user is not selecting any quit or first pressing the escape, the code will continue. Okay, GL clear color buffer bit, GL depth color buffer bit, GL rotate. Yeah, we are rotating this one. We are drawing the mesh. Okay, we are flip the display, and also we are ticking the clock. Okay. Is there anything that we want to make sure before we run? Just run it and hopefully it works. If it's not working, it will become our discussions for our next week. Where's my terminal? Oh, too bad. I closed the terminal. Wait, updating the ZSY. Okay, where am I right now? See the documents. Okay, oh, there are many things in here. I believe it is Python. Where am I put this practicum? CPP project, SPP Photoshop. Corel graphic. Oh, Graphica. Okay. Now we are going to set the what you call it? Virtual environment. Okay. When you're already in the virtual environment, you can try to run the applications. Tada! We have the cube and it is working. So for example, if you want to make it further so you can see the whole cube without any cutting in here, yeah, actually, yeah, you can resize this screen like that. Okay, you can try to make a video, the camera far more further, for example like this one. See, the cube is much more smaller, and now you can see all of it in its axis or rotations. Okay, so this is only a simple explanations of what you are creating today. We already creating a circle, a growing one that will be bounced back if a certain point, which is 200, the diameters of the circle achieve, and also when it reach under 10 diameters, it will grow back. And the cube, it is rotating using the mesh one that we have to define the vertices and also the connections between each vertices to establish a line, a whole presence of a cube. Okay, so that's all the tutorial for today, and hopefully you are understand what I'm saying. In this next meeting, we will try to make it much more interesting. What is that? Please stay tuned for the next meeting, and hopefully in the next meeting, yeah, we will still have a class. I don't like to having creating a video. I still prefer to teach you in the class. We write the code together over there and also creating a module for you, either as a PDF or creating another video like this one, but you have the what you call it, gambaran. You have the not a feature, you have this example, you have the perspective on how it should work. Yeah, we are having our imaginations where we are thinking rotating a cube in front of us, a dice in here. Yeah, but in the class I can draw it, and I love to draw. So in the next meeting we will have a much more interesting topics, and hopefully you will not get bored with this kind of tutorials. And have a nice day. And for those who are celebrating the Chinese New Year, Kung Si Fa Chai. And for those who are not celebrating, have a good day, have a great holiday, and please make your take your time to understand these lessons for this meeting. Have a great day